Welcome to today's lesson. Today we are going to start looking at formulae. The word formulae is the plural for the word formula. So I can have one formula but two formulae. We first need to understand what we mean by a formula. A formula is an algebraic form showing a relationship between variables. A reminder that variables are essentially letters. Characteristics of a formula is that there must be multiple variables present. That means we must have two or more variables. If there is only one variable, this means we only have an equation. A formula must have an equal sign and it can include numbers and symbols. So if we have a look at some formulae, here we have a formula that's v squared equals u squared plus 2as. This is a formula because it's got an equal sign and there is more than one variable. Here we have four variables, v, u, a and s. Our next formula you might recognise from previous maths lessons. We have a squared plus b squared equals c squared. Again, we have multiple variables of a, b and c. And our last example is PQRS equals 10. Again, we've got an equal sign and more than one variable. Some non-examples of formulae include V equals 2 plus 5V. This looks like it's got two variables. However, because both variables are the letter V, there is only one variable, so this is in fact an equation, not a formula. Next, we have a plus b plus c plus d. We do have multiple variables, but this is not a formula because there is no equal sign. Now on to some questions. Today, we're going to look at substituting into a formula. This is where we find the value of a variable if we're told the values of all of the other variables in the question. Substitution in maths works a lot like substitution in sports. In a football match, for example, you would substitute one player for another player. In maths, we are going to substitute a letter for a number. So in our first question, we're being asked to find the value of a, where a equals b plus c. But we're told the value of b and we're told the value of c. So our method here is that we're going to write on the next line the values of the variables that we know. We don't know the value of a, so underneath a we will keep writing a. The equal sign will drop down, but instead of writing b, I'm going to do a substitution and replace b with the number 3. The add symbol will drop down, and then because I know the value of c, I've been told it's 5, I'm going to substitute c with the number 5. This gives me a equals 3 add 5. Well, 3 add 5 is 8. So a equals 8, and that's the answer for this question. On to the next question. Find the value of c when a equals b plus c, a is 9 and b is 4. Like the last question, we will write the values of the variables we know underneath. So we know that a equals 9, b equals 4, but we don't know the value of c. So we've got 9 equals 4, add c. There's two ways to go about solving the value of c here. Either you can treat this like an equation. I need to isolate c by itself, Or I can just look at what I've written down. 4 add something equals 9. Well, the only number that's going to work here would be C equals 5. Just like equations, I can check that I've got the right answer by replacing this C with 5. 4 add 5 does equal 9, therefore I'm correct, C must be 5. Question 3 has A equals B take away C when B is 3 and C is minus 2. Just like the previous questions, we will write down the values underneath. Our A and equals stay the same. B gets replaced with 3. This minus sign will then drop down. Then, looking at the C, well, C is minus 2. The minus I've already written here was the minus between B and C, so I now need to write minus 2 after this minus. So we end up with 3 minus minus 2. A reminder that two negative symbols, when they're next to each other, turn into a positive symbol, and 3 add 2 gives us A equals 5. Question 4. I've got the values of B and A, so I'll write those underneath. So 3 equals 5. This takeaway symbol will drop down, and C will drop down as I don't know the value of C. Now, if we were treating this like an equation, this would be quite difficult, because isolating the minus C, many students will make errors with their negative signs. However, if I think about this as 5 take away a value equals 3, then hopefully we can see that there's only one answer, and that C must be 2, because 5 take away 2 equals 3. Our next question looks a bit more difficult because we've got 3 variables that we need to substitute, but actually it's not too difficult. We use the same method of replacing the variables with the values that we're told. We've got B and C written next to each other here. Be careful, we do not write 32. This is because when letters or variables are next to each other in algebra, this means they're being multiplied together. With variables, we don't have to write a multiply symbol because we know that BC is B times C, but with numbers, we have to write 3 times 2 because 32 is not the same as 3 times 2. So here we have 3 times 2 for BC. Our add symbol drops down, and then D we replace with 5. At this point, because we've got 2 operations, it's really important that we remember the correct order of operations. We will do the multiplying first, so our A and equals will drop down. 3 times 2 is 6, and then the add 5 will drop down to the next line. And then 6 add 5 means we get our answer here of A equals 11. And on to the next question. We start off by substituting in our values. We have A equals 5. Our equal sign drops down. We've got B and C as 3 and 2, but again, remind yourselves that we need to write a multiply symbol between them. We then need to add D, and we don't know the value of D, so we're just going to copy that down to the next line. Here, we need to do 3 times 2 in order to try and simplify this side up. So 5 will equal 6, and then add D. And again, here you've got 2 options. You can treat this like an equation to isolate D by itself, or you ask yourself, what value of D, if I add it to 6, gives me 5? Well, if we're adding something to 6, but we end up with a lower number, what does that tell us about D? Well, D must be negative for us to go down if we're adding it onto 6. So, how much will I need to take off to get down to 5? Well, it will have to be -1. So D equals -1. We can check this because if we do 6 add -1, that would turn into 6 take away 1, which is just 5. On to our next question. We're told the values are now A is 5, B is -3, and D is 2. So again, we'll write those in the correct positions. So we should have 5 equals -3 for B. We're not told the value of C, therefore we are just going to write C in. I don't need to write a multiply sign here because C is still algebra. So we are allowed to write -3C. I still need to add D on, which means I'm going to be writing add 2. This now looks like an equation. Because the equation isn't as straightforward as some of the earlier questions, we are going to use our equation methods to solve this. This means we need to isolate the term that contains the variable, and then we need to isolate the variable. The term that contains the variable is -3C, so I need to isolate that by itself by subtracting 2 from both sides. 5 take away 2 is 3, the equal sign drops down, the -3C will drop down, and 2 take away 2 cancel out. We now need to isolate the variable, which means getting C by itself, which means I need to undo the effect that this -3 is having on C. Be careful here, this -3 isn't subtracting from C, it is multiplying C. So the opposite operation here is dividing by -3. 3 divided by -3 is -1. The equal sign will drop down. And -3C divided by -3. The -3's cancel, leaving us with -1 equals C. This means that the answer, the value of C, is just -1. Our next question is find the value of P for the formula P equals QRS, where Q is 2, R is 3, and S is 5. We don't know the value of P, so when we drop down, P will still be written as a variable. Q, R, and S are all now values, so we need to write values now instead of the letters. However, it's really important again we remember that between these values, because Q, R, and S are all multiplying each other, we write multiply signs. We'll do the multiplication part by part, so 2 times 3 is 6. That means the times 5 will drop down because we've not used it. And 6 times 5 gives us that P equals 30. Our next question is similar but with different values. And also we're trying to find the value of S rather than P. Again, we start off by just replacing the variables with their values. So we've got 2 times 10 S. Well, here we can multiply 2 times 10s together. To multiply these, we just multiply the values together and then write s on the end. So 100 and equals will drop down to the next line. 2 times 10 gives us 20, and then s is written afterwards. Here, we need to isolate the variable of s, which means we need to get rid of the 20. To do that, we will divide both sides by 20. 100 divided by 20 gives us 5. The equal sign drops down, and 20s divided by 20 is just s. So, s equals 5. Our next question is v squared equals ab when a is 2 and b is 8. We don't know the value of v, so v squared and the equals sign will drop down. A is 2 and b is 8, and because they're written next to each other, we need to multiply them. Well, 2 times 8 is 16, so we have v squared equals 16. In order to isolate v by itself, we need to undo the square. This means we need to square root both sides. The square root of v squared is v, and the square root of 16 is 4. But don't forget that with a squared equation, we are going to get a second solution, so we also get the answer of v equals minus 4. Our next question is v squared equals ab when v is minus 15 and b equals 9. Again, we substitute our values, but here, because v is a negative number and we are squaring a negative number, it's really important how we write this out. Whenever we square a negative number, we must write it in brackets. We're still doing minus 15 times minus 15, but it must be written like this. A is still A, and B is 9. Now, I cannot write A and then a 9 after it, because that doesn't make any sense in maths. So, because A has been written first, I must write times by 9 with a multiplication symbol. If we do minus 15 times minus 15, well, because we have two negative numbers multiplying each other, we end up with a positive answer. And 15 times 15, if we use a Napier method, we get 225. The equal sign will drop down, as will the a times by 9. Now, a times 9 is 9a, so we can write 225 equals 9a. In order to isolate the variable, we need to get rid of the times by 9, so we will divide both sides by 9. 225 divided by 9, again if we use a bus stop method here, we end up getting 25. 9a divided by 9 is a. So here, a must equal 25. On to today's final question. We have c equals a squared plus b squared all over d, where a is minus 2, b is 3, and d is 7. Again, we start off by simply replacing the variables with their values. Because a is negative and we're squaring it, again, we must write that in a bracket. B is not a negative number, so I could just write 3 squared without a bracket, and that would be correct. But potentially, it's a good idea to just get into the habit of always writing brackets whenever we square numbers, and then hopefully we won't forget to do it for our negative numbers when we square them. All of this is divided by d, which is 7. We need to do this calculation step by step using our order of operations. So we do our brackets first. So minus 2 times minus 2 is 4. 3 times 3 is 9. And all of that needs to be divided by 7. We now do the numerator first. So 4 add 9 is equal to 13. And that needs to be divided by 7. I know that 13 is not in the 7 times table, therefore I'm just going to leave my answer as 13 divided by 7. So the value of c for our final question is c equals 13 over 7. And that concludes today's lesson on formulae.